Hello students, I am Sonali Kelkar from City International School and today we are going to do the chemistry revision for our exam. Let's start with the first question. Give the names of the following functional group. Okay, if you see the functional group OH. Okay, now this line doesn't show a negative sign, children. This line shows that this OH group is combined to some carbohydrate chain. Okay, it's not a negative sign, so don't consider this line as a negative sign. So let's start. Okay, with the OH. OH is, as we all know, alcohol group, right? OH stands for alcohol group, and COOH, this stands for carboxylic acid group. Okay, so this is the acid group, you call it carboxylic acid group, right? And what about the structure? If someone asks you the structure, how you are going to write the structure? So C double bond, carbon always make double bond with oxygen, children. Just remember, carbon always make double bond with oxygen and one bond with OH and the other bond with any of the compound. Okay, carbon compound. It can be the parent chain, it can be alkane, alkenes, alkynes, right? Now coming to the next question, question number 2, what is the difference in the molecular formula of any two consecutive member of homologous series of organic compound, right? Uh, Before we know that CH2, only CH2, okay? This is the difference in the molecular formula of any two consecutive member of homologous series, right? Okay, so in a form of a formula you have written CH2, but what about the molecular mass? We can find out the molecular mass. What is the molecular mass of CH2? What is the mass of carbon? 12 plus mass of hydrogen 1. So 2 into 1. So what is 12 plus 2? 14 U. Okay, so the difference between the molecular mass of the two consecutive members of homologous series will be 14U. So read the question very carefully. What type of difference they want? Do they want the difference of molecular formula or do they want the difference of molecular mass? Okay, so this should be very clear. Now how to find out CH2? Let's take one example. Let's take the example of methane, CH4, right? This is the first member of alkane group, and after the methane, because we are talking about the two consecutive member, after methane what comes? Ethane, C2H6, right? And they both are the member of alkenes, isn't it? They both are the member of alkenes. Now what is the difference in carbon? Here in ethane the carbons atom are 2, here 1. So difference in carbon atom is single. What about the hydrogen? Here 4, here 6. So difference in hydrogen atoms is 2. So that is why we call CH2 molecular formula difference. Okay. Now coming to the next question. What is meant by the saturated hydrocarbon? Those hydrocarbons in which valency of carbon is satisfied by the single bond. Okay, wherever you find the single bond between the different carbon atoms, that means these hydrocarbons are saturated hydrocarbons. That means all the valency of carbon is saturated. That it doesn't mean that if there is a double bond between the two carbon atom, okay, two valencies are fulfilled, third and fourth. Here also two valencies are fulfilled, third and fourth. Okay, now this is unsaturated hydrocarbon, but that doesn't mean that valency here are not saturated. They are saturated, but this bond can easily be broken down. It can be easily broken down, and then again the carbon is having unsaturated bond, right? So that is why single bond carbon atoms are saturated and double or the triple bond carbon atoms are unsaturated. Clear? Okay, here I can write like this, right? Why are covalent compounds generally poor conductor of electricity? Covalent compounds are generally poor conductor of electricity because they do not form ions. Let's take the next question. Write the structure formula of chloroethane. So whenever you have to write the structure formula, look at the parent chain. This is ethane. So just make the structure of ethane first, and because it is chloroethane, that means one valency of carbon is satisfied with the chlorine and the rest of the valencies are satisfied with hydrogen. Done. Chloroethane is done. Okay, so this is the structural formula of chloroethane. Now coming to the next one, how many covalent bonds are there in a molecule of ethane? So let's form a molecule of ethane. On the top also we form a molecule of ethane. We just have to find out how many covalent bonds are present. So this is 1, 2, 3, 4, 5, 6, 7. So 7 covalent bonds are present. Never take that when the 2 carbon atoms are present, so one carbon atom has 4 covalent bond, so therefore 2 carbon atom will have 8 covalent bond. Don't think in that manner, because we know that one covalent bond is shared between the 2 carbon atoms, so one covalent bond will be less. Okay, so whenever you get the questions like this, there are chances of getting the question like this where you have to count the number of covalent bond. I would advise you to draw the structure and then count, and then you write the final answer. Next question, write the electron dot structure of ethane molecule. C2, first what is the formula of ethane? C2H6, right? And you have to form the electron dot structure of ethane molecule. To form the electron dot structure of ethane molecule, because there are 2 carbons, you draw 2 carbons, just draw a little closer to each other, right? Because you have to draw circle around it. Then we know the valency of the carbon, that means the valence electron in the carbon. There are 4 valence electron. Carbon has the atomic number 6, electronic configuration 2 and 4, and in the electron dot structure we just have to show the valence electron. That is it. We don't have to show other electrons, right? So 4 electrons, so I'll draw 4 electrons over here. For this carbon, I'll take another color. Here also, I'm going to draw 4 electrons, right? I'll take other color, or I could have taken the cross also, but I want to take other color because I have option of taking other color, right? Now, we have hydrogen, right? So for hydrogen, I'll take another color for hydrogen. Okay, now carbon is forming bond with hydrogen. Here also, right? Okay, now this carbon wants in its outermost shell it wants 8 electrons, right? So 1, 2, 3, 4, 5, 6, 7, 8, all the 8 electrons this carbon shared. Now what about this carbon? I still have to put hydrogen, right? So this carbon is also wants 8 electron in its outermost shell so that it can attain octet state. Octet state is the most stable state. Okay, it means 8 electron in the outermost shell. Okay, now hydrogen can share, this hydrogen can share these 2 electron, this hydrogen can share electron with carbon, this with carbon, this 2 electrons. So every hydrogen is getting 2 electron. That means the hydrogen's shell, hydrogen's outermost shell is the first shell, which is getting filled. So its duplet state is getting filled, okay, which is similar to the nearest noble gas. Which is the nearest noble gas of hydrogen, children? It is helium, right? So what is the configuration of helium? In the outermost shell, helium has 2 electrons. Okay, so its duplet state is completed. It is satisfied. That is what That is why we call it a noble gas, right? Helium is the only noble gas which has a duplet state. Rest of the noble gases has octet state. What do you mean by octet state? 8 electron in the outermost shell. That is the octet state. And that is the most stable state. Let's go to the next question. A student detected the pH of 4 unknown solution. Very interesting. A, B, C and D as follows: 11, 5, 7, 2. Predict the nature of the solution. Okay, now you have to find out the nature of the solution. A has valence, okay, A has pH 11, B has 5, C has 7 and D has 2, right? So D will be the most acidic, right? And A will be the most alkali in nature, most very basic in nature, you can say. Okay, and B is again less than 7 acidic in nature. C will be neutral in nature. Now you have to search which color does a neutral substance show in the pH scale. Now coming to the question number 9. Explain isomerism. State any 4 characteristics of isomers. Draw the structures of possible isomers of butane. Butane means C4H10. Why it is C4H10? C4 and H should be 2N plus 2, right? Right. So 2N means 2 into 4, 8 plus 2, 10. So this is butane. Alkane. These are the members of the alkane family. Isomerism, as we know, they have the same molecular formula but a different structural formulae, right? They have same molecular formula but different structural formulae. Being same molecular formula, their chemical properties are same, right? Because they have the same molecular formula. So chemical properties are same, but what about the physical properties? That will be different because they have different structural formula. So structural formula affects physical properties or physical characteristics, right? They differ in structure formula. So because physical, now what are the physical properties? Melting point is a physical property, boiling point is a physical property. So they have different melting point, different boiling point. They differ in the solubility in the same solvent. Okay, so solubility in the same solvent is also differ. Solvent can be alcohol, so their solubility differs in alcohol. Regarding butane, we know the formula of butane, molecular formula of butane is C4H10 and structure formula. So what you have to do, you have to take 4 carbon atoms like this, okay, because these are alkanes, single bond, saturated one, right? So one valency of this carbon is already satisfied. So one valence is satisfied. Then what about the rest of the valencies? 3. So what you have to remember, one line coming out from this carbon. So how many lines should come out from the carbon? 4. Just remember, 4 lines should come out from the carbon. Okay, so 1 is there, 2, 3, 4, and this 2 are there, 3, 4, again 2 are there, 3, 4, again 1 is there, 1, 2, 3. So if you see, the corner carbon's atom will have more number of hydrogen as compared to the carbon atom which are falling in the inside the chain, okay, in the inner part of the chain, right? So yes, you can put HH over here. Okay, so our structure formula is done. This is a basic structure formula of butane, right? So but when I change the position of this CH3, when I change the position of this CH3, what will happen? So I'll do one thing, I'll make 1, 2, 3 carbon, and with this carbon I'm going to attach one more carbon atom, right? So now I will fulfill the valency of carbons. Okay, once you make a chain, you have to fulfill the valency of carbon. This carbon atom, from this carbon atom, 1, 2, 3 lines are already coming out. So 1 will be here, 1, 2, 3, 1 is here, right? So what about this carbon atom? 1 already satisfied, 1, 2, 3. Clear? So now you can put hydrogen like this. And if you remember, children, I told you CH3 is a group which is known as methyl group, and on which carbon atom this methyl group is attached? This is CH3. Okay, this is the extra group which is attached to this chain. So this is CH3 is known as alkyl, ALKYL, alkyl group, right? Because it has single carbon, so we call it methyl group. And on which carbon it is attached? Let me give number to the carbon: 1, 2 and 3, right? Even if I count from here 1, 2 and 3, okay, I have to take the nearest carbon. In both the cases, while you count from left to right or from right to left, okay, the second carbon, this carbon is getting the number 2. So I will write as 2-methyl propane. Okay, 2-methyl propane, because they have asked you to draw the structure of isomers and you don't have nomenclature, so you can just draw the structure like this. Okay. Coming to the question number 10, define olfactory indicators. Name 2 substances which can be used as olfactory indicators. Choose strong acids from the following. Okay, let us do the first part. Olfactory indicators means these are the indicators which gives a particular type of smell when they react with acid or when they react with base, right? Example, onion and vanilla, they are taken as an olfactory indicator. Now, a strong acid from the following. We know that there are 2 types of acid. One acid is organic acid, the other one is mineral acids, right? Organic acid, for example, CH3COOH. This is also known as acetic acid. This is comparatively, these organic acids are comparatively less strong as compared to mineral acid. Mineral acid, H2SO4 is a mineral acid and HNO3 is a mineral acid, which are really strong acids, right? So the next question, a white color powder is used by doctors for supporting fractured bones. Write chemical name and the formula of the powder. The chemical name of the powder is calcium sulfate hemihydrate, right? The formula is CaSO4 dot half H2O. Hemi means half, so half H2O. We also call it plaster of Paris. Plaster of Paris, right? Now, how do we get plaster of Paris? When we heat gypsum. Now, what is gypsum? Gypsum is nothing but CaSO4 dot 2H2O, right? When we heat gypsum at around 373 Kelvin, right, we get CaSO4, that is hemihydrate, calcium sulfate hemihydrate, CaSO4 dot half H2O, right? And what have they asked in the next question? When this white powder is mixed with water, a hard solid mass is obtained. Write balanced chemical equation for the change, right? Now this hemihydrate, once you get the hemihydrate, that is, once you get plaster of Paris, you mix plaster of Paris again with water, you will be back with CaSO4 dot 2H2O. Now what is CaSO4 dot 2H2O? It is nothing but gypsum. So what we understood from this? By heating gypsum we got POP. By mixing water to POP, H2, when you mix water to POP, when you add water to POP, you are getting back the gypsum again. Got it? So this is what we are getting from this equation. Here this is the equation, CaSO4 dot H2O plus, here you can write 1.5 or you can write 3/2. Okay, you can also write 1.5 or 3/2. We have already written H2O. You will get CaSO4 dot 2H2O. Clear, students? Right. Let's do the next one. Explain the action of dilute hydrochloric acid on the following with the chemical equations. Magnesium ribbon. Okay, let's do with the magnesium ribbon. Okay, here the magnesium ribbon Mg plus dilute HCl they have asked. So HCl we have taken dilute one. Remember, this metal reacts with the dilute acid HCl or dilute H2SO4, and it gives us magnesium chloride, and which gas is released? Hydrogen gas is released. Okay. Then sodium hydroxide NaOH plus HCl. This is a very highly explosive reaction. Okay, it's give NaCl and H2O. Now coming to the next, sodium hydroxide is not a this is neutralization reaction. This is neutralization reaction. This is neutralization reaction. Base plus acid. This is base, right? And this is acid. And when base and acids react together, they gives us salt and water. Okay, here water. This is a neutralization reaction, children. Then next one is crushed eggshells. Now we know the eggshells are made up of calcium carbonate, right? So calcium carbonate and HCl, because it has carbonate, CaCO3, remember. So whenever acids react with certain salt of carbonate, carbon dioxide gas is released, carbon dioxide gas is released. Okay, CaCl2, salt is formed. So okay, salt is formed, water is formed, and which gas is released? Carbon dioxide gas is released. This can further be checked by passing the carbon dioxide through a lime water, right? Lime water will turn milky. State reason for the following statements. Tap water conducts electricity, whereas distilled water does not. Why this is so? Because tap water has free ions that conduct electricity. These free ions helps in taking the charges from one electrode to another electrode, right? So that is why tap water conducts electricity, whereas distilled water does not. Next, a dry hydrogen chloride gas does not turn blue litmus red, whereas dilute hydrochloric acid does. Why? Because this is a dry gas where hydrogen and chlorine, or we can say where the hydrogen ion and chloride ions are not dissociated. So that is why you won't find that blue litmus paper. You won't find any change in the blue litmus paper. Whereas if you take an acid in which hydrogen ions and chloride ions are dissociated, okay, and this hydrogen ion is basically responsible for the acidity, right? And that is why it turns a blue litmus paper to red. Coming to the next point, during summer season, a milkman usually adds a very small amount of baking soda to fresh milk. Why do they add? Because alkaline medium does not allow milk to turn sour easily. Okay, otherwise the milk will become sour due to the production of lactic acid. Next, for a dilution of acid is added into water, not water into acid, because when you add water into acid, it will be a very exothermic reaction, okay, and that is why it can lead to any kind of accident. Therefore, the water is added to acid, that too very slowly, and you have to stir it continuously when you are adding water to acid. Next, ammonia is a base but does not contain hydroxyl group. Yes, ammonia dissolves in water and forms H negative. Therefore, it is basic in nature. To the next question, write the chemical formula of hydrated copper sulfate and anhydrous copper sulfate. Okay, hydrated copper sulfate, we know the water crystallization of hydrated copper sulfate is 5H2O. CuSO4 dot 5H2O is a hydrated copper sulfate, and anhydrous means you have removed hydrogen from it. You have removed water, sorry. You have removed water from it, that is why we call it anhydrous, right? So when you heat it, you will get CuSO4 is anhydrous copper sulfate, right? Then what is given over here? Giving an activity illustrate how these are interconvertible. So this activity we have already discussed in my last session, so I'm not going to discuss this activity. You can just go through the activity. Okay, so if you find if you see the reactions taking place during this activity, first blue vitriol, which is also known as hydrated copper sulfate, is heated and you will get white CuSO4.5H2O, right? And when you mix this water with copper sulfate, you will get back the blue vitriol again. Write chemical names and the formula of plaster of Paris and gypsum. This we have already discussed in previous question. So plaster of Paris is nothing but calcium sulfate hemihydrate CuSO4 dot half H2O, half the molecule of water is present here. Then CuSO4 dot 2 H2O calcium sulfate dihydrate. This is the chemical formula and the chemical name of gypsum. Question number 15. State the chemical properties on which the following uses of baking soda are based. An antacid. Okay, now baking soda can also be used as an antacid because it neutralizes the acidity, which is a problem due to the excess amount of acid produced in the stomach. Okay, as a soda acid fire extinguisher, so it liberates carbon dioxide when it is mixed with H2SO4, and this carbon dioxide helps to extinguish fire. To make bread and cake soft and spongy, so it liberates carbon dioxide. Okay, when you add baking soda and when you heat it, you will find that carbon dioxide is getting out from that component, from the bread, from the bread or from cake, and when it is releasing, when the carbon dioxide is releasing, okay, it makes some holes in that batter, and which makes it more spongy, right? So here we can see how washing soda is obtained from baking soda. Write balanced chemical equation. So how washing soda obtained from baking soda? Now baking soda NaHCO3, the formula, when you heat it, we are getting Na2CO3 plus carbon dioxide plus water. Now when you add baking soda on heating gives sodium carbonate, which on crystallization, this sodium carbonate on crystallization will give me washing soda, right? Now washing soda has a water of crystallization 10, Na2CO3 dot 10H2O. Here question number 16, name the natural source of each of the following acids. This can come for the 1 marker, children. Citric acid, lemon and oranges, oxalic acid, tomatoes and guava, lactic acid, curd, and tartaric acid, tamarind. So T for tartaric acid, T for tamarind. So this is how you can learn. So this type of question can come for 1 marker, right? Now coming to the next question, equal length of magnesium ribbon are taken into two test tubes A and B. Then what we have to do, we have to add sulfuric acid H2SO4 in test tube A, and carbonic acid in the test tube B, H2CO3, in equal amounts, right? Now identify the test tube showing vigorous reaction. A will show vigorous reaction. Why it will show vigorous reaction? Okay, give reason to support your answer, because H2SO4 is a strong acid. Okay, H2SO4 is a strong acid. And name the gas liberated in both the tube. That is definitely hydrogen gas, which is liberated in both the tube. Here you can see the equation where the hydrogen gas is released, right? Mg plus H2SO4, MgSO4, the salt has formed and hydrogen gas is released. Here magnesium plus carbonic acid H2CO3, magnesium carbonate plus hydrogen gas is released. Okay, here D part we still have to go. Okay, let's read the further questions. Name the gas liberated in both the tubes. How will you prove this liberation? So how to prove the liberation we have shown with the help of equation, right? And we can take a burning splinter. Yes, we can take the burning splinter near to the gas. It will okay, it will burn with pop-up sound. This shows a gas liberated as hydrogen gas, right? Okay, write chemical equation for both the reactions. So we have written the chemical equation of both the reactions. We will take okay, now yeah, we have taken written the chemical equation of both the reaction. Then out of the two acids taken above, which one will have lower pH value? The weak acid will have the strong acid will have lower pH value. So H2SO4 will have lower pH value, whereas the less concentrated acid will have higher pH value. Okay, which one will have lower pH value? Okay, lower H concentration respectively. Okay, so what is lower H concentration? Lower H concentration will be in carbonic acid, because hydrogen concentration lower H plus concentration if H plus concentration, if it is low, that means the acid is weak acid. If hydrogen concentration is high, that means that acid is strong acid. Mineral acids, in mineral acid, maximum amount of molecules get dissociate, and we get high amount of H plus ions. That is why mineral acids are very strong as compared to organic acid. Coming to the question number 18, dry pellets of a base X when kept in a pen absorb moisture and turn sticky. When kept in a open, absorb moisture and turn sticky. The compound is also formed by chlor-alkali process. Write chemical name and the formula of X. You have to write the chemical name and the formula of X. Describe chlor-alkali process with the balanced chemical equation. Name the type of reaction occurs when X is treated with dilute hydrochloric acid. Okay, now what is this X? Dilute hydrochloric acid. Write the chemical equation. While diluting an acid, why is it recommended that the acid should be added to water and not water to the acid? Okay, so the second part we have already dealt. So we'll be doing the first part of the question. Here the dye palette of a base X when kept in open absorb moisture and turns sticky. So base है तो definitely it will be a sodium and it will turn sticky, it will form NaOH. The compound is also formed by chlor-alkali. So NaOH, we know that chlor-alkali, in chlor-alkali process, where we electrolyzed brine solution. Brine is nothing but salt solution, salt with water, that is a brine solution. Then we have seen that hydrogen gas is released, chlorine gas is released, and NaOH is formed, right? So here we can write down the equation also. Name the type of reaction occurs when X is treated with dilute hydrochloric acid. Now NaOH, when treated with HCl, we are getting NaCl and H2O, right? So this is a neutralization reaction that we got. Then why it is recommended to add acid in water and not water in acid? This is because the process is highly exothermic. If water is added to acid, bottle of the acid will break. Acid has more amount, water has less amount. Acid will produce more heat and bottle will break. A student drops few pieces of marble in dilute hydrochloric acids contained in test tube. Okay, marble is nothing but CaCO3. Dilute hydrochloric acid contained in test tube. The evolved gas has then passed through lime water. Okay, now we have what is formed? Evolved gas, definitely, because This is calcium carbonate, which is a salt of carbonate. Okay, when react with acid, it will always release carbon dioxide, water will be formed, and salt will be formed. Salt, water, and carbon dioxide gas will be released. And when you pass this carbon dioxide gas in lime water, which is nothing but CaOH whole twice, what will happen? Calcium carbonate will form, and because of this formation of calcium carbonate, it turns milky, right? And water is also forming. Clear? Okay. Now, what will happen if excess of gases pass through lime water? If you pass excess of gas through lime water, it will change into calcium hydrocarbonate. Instead of calcium carbonate, you will get calcium hydrocarbonate, which is soluble in water. So the milkiness of the water will get disappear. Very important question. Question number 20. Identify the compound of calcium which is yellowish white powder, and is used for disinfecting drinking water. So the moment you see the word disinfecting water or drinking water, we all know that it is nothing but chlorine, right? Or yeah, chlorine. Write its chemical name and the formula. Okay, how it is manufactured, write the chemical equation for the reaction involved, also list 2 other uses of the compound. Write the balanced chemical equation of, this should be of, chlor-alkali process. Okay, so we shall start with the first one. The compound is bleaching powder. Okay. Bleaching powder, what is the formula of bleaching powder? CaOCl2. CaOCl2 is a bleaching powder. Its chemical name is calcium oxychloride. Chemical name is calcium oxychloride, CaOCl2. It is manufactured by the reaction of solid slag lime, CaOH whole twice, right? Slag lime is calcium hydroxide. When react with chlorine, it gives you bleaching powder, which is yellowish white powder, and water. And this is used as a disinfectant in water, in swimming pools, right? And it is also used for preparation of chloroform. Fine. And then we have to write the balanced chemical equation of chlor-alkali process. In chlor-alkali process, what happened? It is nothing but the salt mixed with water, and we pass electricity. So electrolysis process, by the process of electrolysis, we will get hydrogen, we will get chlorine and NaOH. So these are the products that we get after passing electricity through a brine solution. NaCl plus H2O together known as brine solution, right? So this is all about today's topic, children. Practice a lot, and thank you so much.